Hi everyone, myself Praveena. I am the Assistant Professor of Mathematics in Institute of Aeronautical Engineering College. Today I want to discuss about the question bank discussion on Module 3. What about Module 3 name? Functions of single and several variables. Here in that question bank we have three types. Okay, first one, okay, critical thinking questions, and the second one long answer questions, and the third one short answer question. Each section carries here 20 questions. Okay, first we have to discuss about the part A with critical thinking questions. Okay, what about the first question here? Summarize the conclusion of the Rolle's theorem for the function f of x is equal to x cube minus 6x square plus 11x minus 6 in 1, 3. Okay, we have to verify the Rolle's theorem for the here one polynomial form. What about that? F of x is equal to x cube minus 6x square plus 11x minus 6 in closed interval 1, 3. Okay, here what about the given function? This is one polynomial form. We have to verify each and every condition from the Rolle's theorem. What about the Rolle's theorem here? F of x is continuous and differentiable, and if there exists C belongs to AB such that f dash of C is equal to 0. We have to verify each and every condition. Okay, what about the first one? F of x is continuous, and the second one differentiable, and the third one f of A is equal to f of B. After that, if there exists C belongs to AB such that f dash of C is equal to 0. Okay, first of all, okay, from that first three conditions, first I am observing, first I have to verify the function as differentiable or not. Okay, okay, here the given polynomial is directly on polynomial form, therefore this is definitely it is differentiable. Once observe, f of x differentiable is 3x square minus 12x plus 11. This is f dash of x. Okay, then the function is differentiable. If it is differentiable means definitely it is continuous, right? Okay, therefore, from one of the property, if the function is differentiable means definitely that is continuous. So that here from the Rolle's theorem directly two conditions satisfied. That is f dash of x differentiation, and second one is continuous, and third one f of a is equal to f of b. Here what is a and b? Given interval values, we have to consider 1 and 3. Okay, if the 3 are equal, if there exists C belongs to AB such that we have to find f dash of C value is equal to 0. There C value exists. That is the question answer for the first one. Second one, summarize the conclusion of the Rolle's theorem for the function f of x is equal to log of x square plus ab by x into a plus b. This is also same as the first question. Okay, we have to verify the Rolle's theorem conditions from the function is here logarithmic function, right? Okay, we have to verify each and every condition within the interval a comma b. That is the second answer. Okay, third one, using the Lagrange's mean value theorem to establish the following inequalities. This is different question, but it is very important. What about the question here? Utilize the Lagrange's mean value theorem to establish the following inequalities. What about the question here? X less than or equal to sin inverse x less than or equal to x by root 1 minus x square for 0 less than or equal to x less than or equal to 1. Okay, here using Lagrange's theorem, we have to establish the following inequalities. From that, first we have to take the function from the question. Okay, here we have to assume the function as f of x is equal to sine inverse x. Okay, from that function we have to observe, we have to verify. Okay, for the given function sine inverse x is satisfying all conditions of the Lagrange's. What about the conditions of the Lagrange's? Lagrange's means same as Rolle's theorem. First, we have to verify the continuous for the function within the closed interval a comma b, and it is differentiable in open interval a comma b. And after that, here there exists c belongs to a b such that what f dash of x is equal to f of b minus f of a by b minus a. This is the statement for the Lagrange's. For that, first of all, we have to consider the function f of x is equal to sine inverse x. For this, we have to verify each and every condition from the following theorem, and after that, we can get the value, the equality of x less than or equal to sine inverse less than or equal to x by root 1 minus x square. Each and every theorem and that related problems explained in the previous concepts. Okay, go through that. Each and every answer is there in that previous classes. Okay, and this is the third one. And then fourth one, solve approximately the value of fifth root 245 by using Lagrange's mean value theorem. This is also same as the last question. By using Lagrange's, we have to find the approximate value of fifth root 245. For that, we have to take the function fifth root of x. From that, we have to verify is it differentiable, continuous, and each and every condition from the Lagrange's mean value theorem. Okay, after getting that answer, if you have any doubt from that calculus, for that answer, if you have any doubt from the calculus directly, fifth root 245 value is equal to how much? Okay, from the Lagrange's also we get the same value. That is the verification of the answers from the scientific calculators. Okay, and the fifth question, select the Cauchy's mean value theorem for the function f of x is equal to x cube and g of x is equal to 2 minus x in closed interval 0, 9. This is the another theorem. Previously we discussed Lagrange's and Rolle's theorem. Now the fifth question comes from the Cauchy's mean value theorem. What about the statement same as the two? First we have to, the function is continuous in closed interval a comma b. It is differentiable in open interval a comma b, and g dash of x is not equal to 0. If the three conditions satisfied, if there exists c belongs to a b, what about that formula f dash of c by g dash of d is equal to f of b minus f of a by g of b minus g of a. You have to verify each and every condition for the given two function. One is f of x is equal to x cube and another one is g of x is equal to 2 minus x in the closed interval 0, 9. Okay, this is the verification of the Cauchy's mean value theorem for the functions f of x is equal to x cube and g of x is equal to 2 minus x. Once observe, these two are algebraic equations, so that definitely these two are differentiable, and if it is differentiable means definitely it is continuous. Okay, that is the fifth question. Next, sixth one, if u is equal to x plus 3y square plus z cube, comma v is equal to 4x square yz, comma w is equal to 2z square minus xy. Then apply dou of uvw by dou of xyz at 1 comma minus 1 comma 0. Okay, this is what, this is different type of question. Okay, this is the first part, this is the second part of the module 3. This is comes from the Jacobian form. Okay, here they are given three functions. Okay, three functions within the variables, how many there? X comma y comma z. U in terms of xyz, v in terms of xyz, and w is in terms of xyz. For that we have to find dou of uvw by dou of xyz. What about the formula for that? This is straight of dou u by dou x, dou u by dou y, dou u by dou z. Next, dou v by dou x, dou v by dou y, dou v by dou z, dou w by dou x, dou w by dou y, and dou w by dou z. Okay, we have to find each and every function differentiation with respect to x, y, z. Okay, and after that we have to substitute x, y, z values 1 comma minus 1 comma 0 in the Jacobian formula. This is a formula. Okay, previously we discussed this concept also clearly. Okay, go through that. In the next seventh one, identify whether the following functions are functionally dependent or not. If functionally dependent, find the relation between u is equal to x plus y by 1 minus xy, comma v is equal to tan inverse x plus tan inverse y. This is also same as sixth question. What about the Jacobian formula? This is the Jacobian formula. Here for the seventh question, what they are asking, okay, first we have to show that the functions are functionally dependent or independent. Here once observe whatever the functions u and v, u is in terms of two variables, that is x and y, v is also in terms of two variables x and y. Okay, for that we have to find Jacobian value, that is det of dou u by dou x, dou u by dou y, dou v by dou x, and dou v by dou y. If it is not equal to 0, definitely that is functionally independent. Independent. Okay, if it is independent means definitely for the given u we have some relation. Okay, first we have to verify the functions are independent or dependent. If it is independent, there is no relation. If it is dependent means definitely the two functions are in some relation. We have to find that relation also. Okay. Here the functions are dependent means they definitely have to find relation of the two functions. Okay, that is the concept of the seventh one. In the eighth question, a rectangular box open at the top is to have volume of 32 cubic. Find the dimension of the box requiring least material for its construction. This is also comes under the same topic already we discussed. Okay, ninth question. Identify whether the following functions are functionally dependent or not. If functionally dependent, find the relation between them. This is also same as the previous question. Here the function is in two variables. Here the function x and y within the variables u and v. For that we have to write down the formula of the Jacobian. If it is equal to 0 means, okay, then the functions are dependent. We have to find the relation between x and y. That is the ninth question. And the 10th question, find the minimum value of x square plus y square plus z square given that xyz is equal to a cube. Once observe here, learn to recall the concept of the Lagrange's multipliers. Okay, here this 10th question comes under which topic? Lagrange's multipliers. Okay, Lagrange's multiplier is alternative method for finding minimum or maximum values of the function. What about the function there? F of x is equal to small f of xyz plus lambda into pi of xyz. For the given function, first we have to assume one is function and another one is the condition. Okay, here the function is this and the condition is this. Here we have to substitute and differentiation first with respect to x and equal to 0 and differentiate with respect to y and equal to 0 and differentiate z with respect equal to 0. Okay, from that according to the concept of the Lagrange's rules, okay, we get the minimum value of the 10th question. Okay, that is the concept of Lagrange's. Okay, these are the critical thinking questions. Critical thinking question part A comes under how many questions? Only 10 questions. Okay, next part B, long answer questions. That is, show that the Rolle's theorem. First question, show that the Rolle's theorem is applicable for the function f of x is equal to e power x sin x in the interval 0, pi. Already we discussed in the critical thinking first question. Okay, same as that concept there. Here we have to verify each and every concept of the Rolle's theorem for the function f of x is equal to e power x sin x. Okay, what are the conditions for the Rolle's theorem? For the given function is exponential into trigonometric, so that we have to verify it is differentiable and continuous, and f of a is equal to f of b. After that, if there exists c belongs to b such that f dash of c is equal to 0, we have to verify each and every condition for the f of x. Okay. Second question also same. Verify Rolle's theorem is applicable for the function f of x is equal to e power minus x into sin x minus cos x in the interval pi by 4 comma 5 pi by 4. This is also same as the last question. First question, I have to verify each and every condition from the Rolle's theorem. Third one, show that the Lagrange's mean value theorem is applicable for the function f of x is equal to x cube minus x square minus 5x plus 3 in the interval 0 comma 4. Okay, already we know that what about the Lagrange's theorem? It is continuous and differentiable, and f of a, f dash of c is equal to what? F of b minus f of a by b minus j. Okay, from that we get c value. Okay, from here the function is algebraic function, so that definitely it is differentiable and it is continuous. After that we can find c value. Next, if a less than b, show that b minus a by 1 plus b square less than tan inverse b minus tan inverse a less than b minus a by 1 plus a square. Select Lagrange's mean value theorem and hence deduce the following. Okay, this is important question. From the Lagrange's, first we have to show the condition of this. Okay, after that, from the condition we have to deduce the following two conditions, two equations. Okay, from that, first of all we have to assume from the question what is the function. What is the function? Here f of x is equal to, have to assume that as the tan inverse x. For the function we have to verify each and every condition from the Lagrange's mean value theorem. What are the conditions for the Lagrange's? It is continuous or it is differentiable, and after that we have to c belongs to b such that f dash of c is equal to what? F of b minus f of a by b minus a. Okay, from that, first of all we have to assume tan inverse x. After that, verify each and every condition for the Lagrange's. From that we get directly that first part of the answer. From that, here we have to assume a and b values. Okay, for that assumption only we get first deduction part and second deduction part. Already we explained clearly in the previous classes. Go through that. Okay, this is the fourth question. Next, find the value of c in the interval 3 comma 7, closed interval 3 comma 7 for the function f of x is equal to e power x and g of x is equal to e power minus x using Cauchy's mean value theorem. Already we discussed what about the condition for the Cauchy's mean value f dash of c by g dash of c is equal to f of b minus f of a by g of b minus g of a. This is the condition. Okay, we have to verify the functions are here exponential. First of all, we have to verify the function is continuous and differentiable. After that, find c value from the formula. That is the fifth answer. And similarly, sixth one also Cauchy's mean value theorem, but here the functions are f of x is equal to root x and g of x is equal to 1 by root x, same as fifth question. And next, seventh one, select Cauchy's mean value theorem for the functions f of x is equal to x square and g of x is equal to x cube in closed interval 1 comma 2 to find the value of c. This is also same as fifth and sixth question. Same theorem, same concept. And eighth question, choose the Rolle's theorem to find c value for the function f of x is equal to x minus a whole power n into x minus b whole power n, where m comma n are positive integers in a comma b. This is from Rolle's theorem, same as first and second questions. And next one, select the mean value theorem for the for 0 less than a less than b and show that 1 minus a by b less than log b by a less than b by a minus 1 and hence deduce 1 by 6 less than log 6 by 5 less than 1 by 5. Okay, here once observe, select the mean value theorem. Which theorem is applicable for this conditions? This is comes under the Lagrange's mean value theorem. Okay, from that we have to assume from the question, what about the function here? We have to assume the function as here clearly, we have to assume log x. Okay, I'm assuming the function as log x. From that, I'm verifying each and every condition from the Lagrange's mean value theorem. Okay, from that we get directly this part. Okay, first part of the answer. After that, I'm assuming there, okay, b and a values. Here, what about b and a values? B as 6 and a as 5. B as 6 and a as 5. Okay, this is the concept of the 9th question. And 10th one, find all values of C between A and B which satisfies Lagrange's mean value theorem for the function f of x is equal to x minus 1, into x minus 2 into x minus 3 in closed interval 0, 4. Okay, this is comes under Lagrange's mean value theorem. Already we discussed with the third and fourth question. Okay, already we discussed with the previous questions. So go through that from the condition of the Lagrange's. That is the 10th question. From the 11th question onwards, this is different. What is x here? If x is equal to u into 1 minus b, comma y is equal to ub, then show that j into j dash is equal to 1. Here what are the functions? X plus y square is equal to u, y plus z square is equal to v, and z plus x square is equal to w. Find the value of dou of xyz by dou of qbw. This is comes under the Jacobian. If the function is in 3 variables, so that according to that you have to write the formula and find out the values of find out the Jacobian value of the given functions. That is the concept. And the 12th question, if u is equal to x square minus y square, v is equal to 2xy, where x is equal to r cos theta, y is equal to r sin theta, then show that dou of ub by dou of r comma theta is equal to 4r cube. Okay, here once observe the function we are in terms of xy, and given what about x and y here within the terms of r and thetas. Okay, according to that, write down the formula of the Jacobian and we have to show the value is equal to 4r cube. This is also comes under the Jacobian. And the 13th question, if x is equal to e power r secant theta, y is equal to e power r tan theta, then prove that dou of xy by dou of r theta into dou of r theta by dou of xy is equal to 1. This is also comes under the Jacobian. Go through according to this conditions, formulas. Okay, dou of xy by dou of r theta means xy is in terms of r theta. And second part, r of theta by xy means r theta, write it in the formula of xy. If that multiply that two, that definitely it is equal to 1. Okay. 14th question. If u is equal to ux is equal to yz, vy is equal to zx, wz is equal to xy. Then find the Jacobian of dou of xyz by dou of upw. This is also same as the last concept. Next, make use Lagrange's multipliers method to find the minimum value of the function x square plus y square, comma, subject to the condition ax plus by is equal to c. Okay, already we discussed with the one question previously, Lagrange's method of multipliers. Here we have to find the minimum value. What is the formula? Capital F of xyz equal to what? Small f of xyz plus lambda into pi of xyz. From the differentiate with respect to xyz and equating with 0, from that we get here minimum value. 16th one, find the maximum value of a rectangular parallelepiped that can be inscribed in a sphere using Lagrange's method. Okay, this is also same as the previous question. Next, find the volume of the largest rectangular parallelepiped that can be inscribed in the ellipsoid. Okay, this is also comes under Lagrange's, and 18th question also comes under the Lagrange's, and 19th question also comes under the Lagrange's, and 20th question is also comes under the Lagrange's. Each and every question clearly we explained in the previous classes. Okay, go through that. Okay, these are the questions from the long answer. Next, I'll discuss with the short answer questions. Very simple. How Rolle's theorem is applicable for any function f of x in the interval a comma b. Okay, just asking, this is short answer. How Rolle's theorem applicable? It is continuous, differentiable. Okay, and after that f of a is equal to f of b. There only, okay, Rolle's theorem is applicable for the function. After verifying, okay, that there exists c belongs to a b such that what? F dash of c is equal to 0. Okay, that is the answer for the first question. Similarly, second one, how Lagrange's mean value theorem applicable for the function f of x? This is also Lagrange's. Okay, through the Lagrange's theorem. Okay, third one, this is how Cauchy's mean value theorem is applicable for the function f of x in interval a comma b. This is also comes under the Cauchy's mean value theorem. And explain Rolle's theorem geometrically. Okay, this is also theoretical question. It is very clearly, it is there in the previous classes. Okay. Next, same as fifth one, explain Lagrange's mean value theorem geometrically. Okay. And sixth question, illustrate an example of function that is continuous on -1, 1 and for which mean value theorem does not hold. Okay. Here we have to verify. Okay, where the condition is not satisfied for the question. Okay, this is comes under maybe Lagrange's. From that Lagrange's, we have to verify each and every condition. In the seventh one, make use of Lagrange's mean value theorem to find the value of c for the function f of x is equal to log x. Okay, this is also simple by using Lagrange's. And next, explain why mean value theorem does not hold for f of x. That means what? Where the condition is not satisfied for the function, okay, we have to verify each and every condition for the Lagrange's. In one case, it is not equal, so that condition is not satisfied. That means the Lagrange's mean value theorem does not exist for the given function. Next, ninth question, identify the region in which is increasing. F of x is equal to 1 minus 4x minus x square using mean value theorem. This is also comes under Lagrange's mean value theorem. And 10th one, if f dash of x is 0 throughout an interval a comma b using mean value theorem, show that f of x is constant. This is also comes under Lagrange's mean value theorem. And next, if f of x is equal to u square by v and y is equal to v square by u, find the value of dou of v by dou of xy. This is comes under Jacobian. Okay, Jacobian. From that here the function is comes under x is in terms of uv, y is in terms of uv. That means two variables. And next, 12th question, find the stationary points of the function f of x. Okay, stationary means what? We have to find out the maxima or minima value for the function with respect to the concept of the maxima or minima. Next, 13th question, f of x is equal to u into 1 minus v, comma y is equal to uv, find the value of j dash. This is also comes under Jacobian. And 14th question, find dou of xyz by dou of uvw if u is equal to 2yz by x, v is equal to 3zx by y, and w is equal to 4xy by z. Okay, this is also comes under Jacobian. And 15th question also comes under Jacobian. If the question is in 3 variables, means function, write it as the formula in 3 variables. If the question is in 2 variables, question means functions are in 2 variables, write it is the formula in the 2 variables for the Jacobian. Okay, next, if x is equal to r cos theta, y is equal to r sin theta, then find j. This is also comes under j, Jacobian. There the function x is in r comma theta and y is in r comma theta according to the right of formula. And 17th also same, x is equal to r cos theta and y is equal to r sin theta. And 18th question, if x is equal to uv, y is equal to u by v, then find Jacobian. Okay, this is also comes under Jacobian. In 19th question, if u is equal to x square, v is equal to y square, then find j. Okay, that is also comes under Jacobian. And the last 20th question also comes under, if u is equal to 2axy, v is equal to a into x square minus y square, then find the Jacobian. These all comes under the Jacobian. If the functions are in two variables, means write it as the formula with two variables, and after that find the determinant value. The function is in three variables, means according to that write it as a formula for the three variables and find the k value. Jacobian value. Determinant means Jacobian value. Okay, these are the questions from the module 3. Okay, next class we will discuss with the other modules 4th and 5th. Okay, thank you. Thank you for all.
Like, share and subscribe. Hit the bell icon for more updates.